Hi, welcome, this is Clement Elektor. In this video I will demonstrate a project posted at the Elektor Labs website. The project that I selected is the PRBSynth1, designed by RS Elk, whose real name is Raymond Schouten, and he's from the Netherlands. Raymond sent me a bare PCB for the PRBSynth1 he had left over, and an Arduino Pro Mini, and a few other parts so that I could build my own instrument and give it a try. And so I did. You know, you too can post projects you did or that you are working on at the Elektor Labs website. It is a great place to get feedback and help. Also, when you post a project, it is evaluated for publication in the Elektor magazine. So if that happens, you become a published author. So back to our synthesizer. What exactly is the PRBSynth1 and why does it have such a strange name? Well, it's a small sound synthesizer running on an Arduino Pro Mini. The surrounding electronics are very simple and most of it is even optional. All its parameters are controlled by either 8 potentiometers that I did not mount or over MIDI by using CC controls. The unique selling point, to use that term, of the PRBSynth1 is that this synthesizer doesn't have an oscillator to create sounds with, but uses a noise generator instead. So the sounds it produces are based on noise instead of sines, saw, square waves or even samples. Noise can be created with analog circuitry like a reversed bias transistor or a Zener diode, but it can also be created digitally with a bit of software, and that is what this synth does. The technique behind it is based on a tapped shift register with feedback. With the right feedback taps in the right places, the output bit stream becomes almost random. Such a bit stream is called a Pseudo-Random binary sequence, or PRBS. And now you understand the name of the synthesizer, Pseudo-Random binary sequence synthesizer. It is called Pseudo-Random because the bit stream will repeat after a certain time. When the shift register is long enough, the period of the bit stream becomes quite long, and it can be considered noise. So, to be technically correct, such a noise generator is in reality an oscillator, but with a complex waveform and a very long period. For the purpose of this project, it is considered white noise. White noise has a horizontal spectrum, meaning that every frequency has the same intensity. This is much like white light, which explains why it is called white noise. It sounds like a radio in between two stations. By emphasizing certain parts of the spectrum, other noise colors can be obtained. The PRBSynth1 also features pink and red and popcorn noise. Pink noise, or 1/f noise, has a spectrum with a slope of -10 dB per decade. The spectrum of red noise, or Brownian noise, has a slope of -20 dB per decade. Popcorn or crisp noise is obtained by clipping the output of the noise generator. There are 2 flavors. The PRBSynth1 also lets you control the length of the random number sequence to obtain a gradual change from noise sounds into pitched sounding repeating patterns. This is called pattern mode. The pitch of these patterns is mapped to musical notes and can be played with a MIDI keyboard. The output of the noise generator is passed through a filter. Several types are available: low pass, band pass, high pass and band reject or notch. The low pass and high pass filters both have 2 slopes, 6 dB per octave or first order and 12 dB per octave or second order. The cutoff frequency is adjustable, but not the quality or Q factor. Instead, except for the first order low and high pass filters, all other filters have several Q preset values. The 12 dB low pass filter has 3 Q presets. The band pass filter has 5 and the 12 dB high pass filter and the notch filter both have 2 Q presets. This gives a total of 14 filter presets. There is a 15th which is a fixed frequency low pass filter but with a modulated sample rate. The 3 LEDs shows which filter variant is active. Their intensity is a measure for the cutoff frequency. A low frequency oscillator, or LFO, adds a bit of variation to static synthesized sounds. The LFO can modulate either the filter cutoff frequency or the signal amplitude, but not both at the same time. It can also modulate the length of the noise generating shift register and the stereo position. The rate of the LFO is adjustable from 25 Hz down to 1 cycle every 2 minutes, so this is really slow. Besides the rate control, the LFO disposes of 16 different waveforms, ranging from a bunch of sawtooth variants and a triangle to a few pulses and random waveforms. The LFO itself can be modulated too, as it has 4 operating modes. First of all, it can be unmodulated, meaning that it's active all the time. Then there is active, but only when pressing the trigger button. The third option is to add accents from a pattern table. With the LFO mode potentiometer, you can choose between 48 rhythmic patterns, most with a length of 8 steps and 12 with a length of 6. The fourth option gives you 16 LFO depth sweep patterns, 3 of them with a length of 12 bars or measures, and the others have a length of 16. Again, you use the LFO mode knob to select the sweep pattern. LFO speed and depth are shown by a single LED. Overall volume is set manually, but stereo panning is controlled by either the LFO or by a dedicated free-running modulator with its own rate control. There is also a manual mode, so you can pan the sound to a fixed position. All this is controlled by the pan pod, and 2 LEDs show what is going on. As you have seen and heard, the PRBSynth1 is a peculiar little synthesizer with many possibilities, even though it runs on an Arduino Pro Mini. All the details to build and program it, together with sound examples, can be found at the project's webpage at Elektor Labs. There you will also find a link to Raymond's webpage that hosts a wealth of nifty, low-resource, low-budget synthesizer tricks. If you too have done a project that you would like me to present in a video, post it at Elektor Labs and let me know in a comment or by email or on Twitter. I hope to hear from you soon. Okay, that's it. I hope you found it interesting. Please don't forget to subscribe to our channel and click or tap the bell button. Thank you for watching.